We are being given the function f of xy equals x cubed y squared plus 2x squared y minus 3y to the fourth power. And we are using this function to solve for the partial derivative of f with respect to x. But before we actually solve this, we have to write some side notes. The symbol for the partial derivative is called del. And when we say the partial derivative of f with respect to x, it means we're differentiating with respect to x, and we must treat y like a constant. Also, to solve this, we're going to use the power rule. If you don't remember, a constant's derivative is 0, and to do the power rule, you write the power in front of the coefficient, and then you subtract 1 from the power. Here's a quick example of the power rule in use. So the equation we have here is f of x equals 3x squared plus 1, and we're going to find the derivative. So f prime of x equals 2 times 3x to the power of 2 minus 1 minus 0. So we got the 2 times 3x by bringing the 2 down, and then we subtracted 1, and the derivative of the 1, which is a constant, is 0. Since once we simplify that, we get f prime of x equals 6x. Now that we have all that down, let's go back to our problem. As you can see, we took each part of the equation and found the derivative as if y was a constant. For x cubed y squared, we brought the 3 in front of the x and then did 3 minus 1, which is 2. And y squared is a constant because it's y. So for that part, we now have 3x squared y squared. For 2x squared y, once again, we're treating y like a constant, and we're bringing the 2 down in front of the x. So we're multiplying the 2 by the existing 2 and getting 4. So we have 4xy. And then for negative 3y to the fourth power, y, once again, is being treated like a constant. And what's the derivative of a constant? 0. So this brings us to our final answer. The partial derivative of f with respect to x equals 3x squared y squared plus 4xy. But why does this matter? What even is the partial derivative? The partial derivative is actually pretty useful. We can make an example of it in use by using Trefula Valley. Trefula Valley is a very hilly place. We can say the height of the hill at any point is h, and wherever you stand is given by the coordinates x, y. If you walk along the x-axis, your slope is going to be the partial derivative of h with respect to x, and vice versa for y.
You don't know how, but you will learn how to derive a partial derivative. But it seems like the best way to do this is by using the power rule.
Start with del.
It's the symbol for the partial derivative, which is a multivariable function, so we say, let's derive.
Let's derive, let's derive. Like an f of x comma y. You must treat y like a constant. Let's use the power rule and derive with respect to x. We say, let's derive.
Let's recap about powers. Put it in front of the coefficient. La 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 la, and subtract 1 from the power.
So like a 3xy plus a 4x cubed y squared, solving with respect to x with our powers. So 3y plus 12x squared y squared. Well, guess what? You derive.
Let's derive like an f of x comma y. You must treat y like a constant. Let's use the power rule and derive with respect to x. We say let's derive.